Hello viewer, you are watching Elimu TV. Welcome to Form 1 Physics, our lesson 4, and today we are discussing measurement 1. This is our topic number 2, and we are going to focus our discussion on definition of length, area, volume, mass, density, time, and their SI units. So today basically we are going to discuss about measurement 1, meaning that we also have measurement 2 that we shall discuss later. So before we begin, my names are Benjamin K. Makanda, and I hope you're going to enjoy the lesson. So let's begin our lesson by looking at the specific objectives of the lesson. So our lesson objectives today, by the end of the lesson, the learner should be able to define length, area, volume, mass, density, time, and the SI units of these quantities. Later on, we are going to refer to these quantities as the basic physical quantities. So we have to state their SI units. So lesson preview is our next agenda that we have to look at, and this is the order of our lesson. We review lesson 3, and in lesson 3, it was actually introduction to physics, and we defined physics as a branch of science that deals with the study of physical properties of matter and how they relate to the production of energy. Now today we want to expound on that and look at how we can now apply the knowledge that we learned in physics in actually doing the measurements of the quantities that we have just highlighted. So we review that lesson. Then after that we now move to definition of length, area, volume, mass, time, and their SI units. After which we shall attempt some questions at the end of the lesson. That would be your assignment for the end of the day. Now we want to begin by looking at measurement. What's measurement in your own understanding? How can you define measurement? And what's the significance of measurement in science, especially physics? So what's the origin of measurement? So this is what we say about measurement. In order to measure, we need to know or define the quantity to be measured and the units for measuring it. So before you have to measure, you have to define what measurement is and decide which units you are going to use in order to measure any given item or a physical quantity. For example, if you go to a shop and you want to buy sugar, you say, I want 1 kilogram of sugar. So the units of that measure has already been given. Now, how do you measure that? That's what we have to put into consideration. So that's one. The other thing that we have to note about measurement is that this measurement did not just come on its own. In 1971, a system known as the International System of Units, otherwise known as a System International, and 7 basic units were agreed upon. So the idea behind measurement was discovered in 1971 in Latin, and they came up with a system that can be used as a benchmark for doing the measurements of various physical quantities. In real sense, we have 7 basic physical quantities that we have to discuss, which were first discovered in 1971. So this is the brainchild of measurement. The other thing that we have to note about measurement is that in measurement, other quantities can be obtained from the basic quantities and are referred to as derived quantities. Later on, as we're going to see, we have the basic physical quantities. Actually, they are the parents of the SI units. Out of these units, you can also derive other quantities, and these quantities are what we call derived quantities. So if I have just to take an example of a basic physical quantity is a meter. Meter is the measure, actually is the unit that is used to measure the distance or the distance between 2 points. We measure it in meters. Otherwise, if the distance is too short, then we can use other quantities as centimeters or millimeters. Now the meters becomes the parent units, and then the centimeters and the millimeters becomes the derived quantities. To help us understand this, let's have a look at this table, which is a summary of what we are talking about. This table is a summary of basic physical quantities that we talk about. They are 7 basic physical quantities, out of which other derived quantities are obtained. So the basic physical quantities are as follows from this table. Now the first one is length. That's the first basic physical quantity, and the SI units, the international units of measure of length is meter. The symbol is M. Then we have mass, which is measured in kilograms. That is the SI units, and then the symbol is kg. We have time. Time is measured in seconds, and the symbol is S. Electric current is measured in amperes, and the symbol is A capital. We have thermodynamic temperature, which is measured in Kelvin, and the symbol is K. We have luminous intensity, and this one is measured in the units called candela. The symbol is C capital and then D small. Then we have amount of substance, which is measured in the SI units is small, and then the symbol is MOL. These 7 are the basic physical quantities that can be used to measure various parameters. Just ask a question. If we can measure length in meters, maybe what are some other units that can be used to measure length apart from meters? If the distance is too long, which other units do you use? You can use kilometers, you can use meters, you can use centimeters and etc. So centimeters, millimeters and kilometers, those ones are called derived units or derived quantities, because we derive them from what? From meters. Otherwise, the SI units for length is meters. Mass is measured in kilograms. The derived units for kilograms are grams and tons. Seconds, we have milliseconds, we have microseconds and etc. Amperes, the same, milliamperes and etc. So those units that we derive from the basic physical quantities are what? We call basic physical quantities. Now moving on, we now want to look at these quantities one by one, and the first quantity we are looking at is length. Therefore, what is length? So if you move your hand from the table to your face, you have moved that from one point to the other. How do you define that point? Or if you move from your desk to your colleague's desk, you have covered some distance. So that one becomes length. Therefore, what is length? Length is defined as the measure of distance between 2 points in a space. This is the measure of distance between 2 points in space. Let's take an example. If you are sitting next to a door or just directly to the door of a class, and then you move from that point where you are sitting to the back of a class, then you should have moved from one given point to the other point. Let the original point where you are sitting be point A. So moving from that point to another new point, then you have covered some distance. So that distance that you have covered actually is covered within 2 points, then we call that one length. Therefore, this is the measure of distance between 2 points. Let's look at this, which can help us understand what length is. So we have 2 points here. We have point 1 and point 2. An individual moves from point 1 to point 2. So if you move from this point 1 to point 2, then you have covered some length. That's why this one is able to confirm that length is actually the distance between 2 points in space. Moving on, still on length, the SI units of length is meter. We have just seen from the table. So meter is the SI units of length. Therefore, if meter is the SI units of length, then 1 kilometer is equals to 1,000 meters, 1 kilometers is equals to 1,000 meters, meaning that 1,000 meters make 1 kilometer. Then 1 hectometer is equals to 100 meters. So what we are trying to say here is that a kilometer is a derived quantity of a meter, and therefore how many meters make a kilometer? 1,000 meters make a kilometer. Therefore 100 meters will make 1 hectometer, and a hectometer is again a derived quantity of a meter. The other thing, 10 meters is equals to 1 decimeter. D, we are using capital D. 1 decimeter is equals to 10 meters. Again, decimeters is the SI is the derived quantity of a meter. The last one in this group is 1 millimeter is equals to 0.01 meters. Therefore, the question that I pose at this stage, how many meters are there, or how many centimeters are there in 1 meter? How many centimeters are there in 1 meter? Using these examples that we have here. So we are still talking about length. Another thing that we have to say about length, you have to look at how length is measured. What instrument do you use for measuring length? Length is measured using a meter rule, and meter rules come in different sizes. We have those ones of 100 centimeters, tape measure of 100 meters, 300 meters, and 500 meters. So we have 2 instruments here that are used to measure length. That is a meter rule. We have a tape measure. So looking at a meter rule, we are talking about a meter rule, but not a ruler. A ruler has L-E-R at the end, but a meter rule does not have R at the end. What's the difference? When you look at the calibration of a meter rule, the 0 begins at the edge of that meter rule. That's why it is different from the ordinary ruler that we use. The ordinary ruler, the zero begins at slightly after the edge, but a meter rule the zero begins immediately at the edge of the meter rule. So we are talking about the meter rule. We have a tape measure. These are some of the equipment that we can use to measure length. Just to have a look at some of them, this one is a meter rule that we have. We have a meter rule here that we use in the lab, and this one is used to measure length. We also have a tape measure that is here, which is also used to measure length. So these are some of the equipments or apparatus that can be used to measure length in the lab. So that's the first basic physical quantity that we have just looked at, that is length, and we have looked at what length is, the SI units of length, the derived units and all that, and how they can be measured. Now we are moving to the second one, which is actually a derived quantity of length, and this one is area. The next one is area. And I want again to pose a question. You must be sitting in class and you are occupying some space around you. So how can you define that space that you occupy within your class? So that once seated, no one else can come and occupy that point. That definitely becomes an area. So what's an area? Or what is area? This is the measure of the extent of surface. The measure of extent of surface becomes an area. For example, if you want to measure the extent of floor, then the extent of floor becomes our area. So this is the measure of extent of surface. And to help us understand, let's have a view at this. This is our area. So the extent of this surface here, we have a surface here that has some units, square units. We can actually calculate that area. So this one becomes our area. The extent of any given surface becomes the area. Now, what else do we need to know about area? It is a derived quantity of length. As we have said, it's a derived quantity of length, and we are going to see why are we saying that it's a derived quantity of length? Because of this. It is SI units are square meters. So it means that you take meter multiplied by meter, you get meters squared. It is SI units are square meters, and therefore it's a derived quantity of length. The other thing about it is that we can also look at some of the multiples that can be used to measure area, and they include other units are centimeters squared, kilometers squared, etc. So these ones becomes the derived units or derived quantities from length. Otherwise, something very important to note here is that area is a derived quantity of length, and this one can be confirmed from the way these units are being used to square the units. Still on area, how can we be able to calculate area? How do you calculate area in your mathematics? Formulas are used to determine areas of regular bodies, while for irregular bodies, an approximation of area is used. For regular bodies that have definite shapes, we can use actually the known formulas to calculate their areas. But irregular objects or bodies, we have to actually approximate their area, because there are no definite formulas that can be used to calculate their area. So we have a summary of the formulas used here to calculate areas of different shapes of objects. So we have a square there, we have its area. How we can calculate area? We have triangle, we have a rectangle, we have a parallelogram, trapezium, we have ellipse, we also have a cycle here. So they have their own areas on how we can be able to calculate them. These ones here, they are called regular objects because they have definite shape, and therefore we can employ a known formula to calculate their area. So that is all about area. Now let's move on to the next one, and the next one we are looking at is volume. What's volume? This is the amount of space occupied by matter. The amount of any given space that matter occupies is known as volume. So that amount occupied by matter, we call it volume. So if you take some water and you pour into a cylindrical glass, then the space that water occupies within the cylindrical glass becomes our volume. The other thing that we have to note about matter is that the SI units of volume is cubic meter. So what can you say about volume? Any relationship between volume and length? Yeah, there is. Just like area, volume is also a derived quantity or a derived unit of what? So other units or sub-multiples that can be used to calculate volumes include centimeters cubed, millimeters cubed, and liters. This one again becomes the derived quantity, they become derived quantities. And this one is what makes volume to be a derived quantity of length. So to help us understand what volume is, let's have a look at this diagram here. Now this diagram is in form of a cuboid. So how do we calculate the volume of a cuboid? It's given by length multiplied by breadth multiplied by height. That one becomes our volume. So our volume is going to be length multiplied by breadth multiplied by height. So that one becomes a space occupied by matter. I hope you understand now what volume is. You can actually be able to picture from this particular diagram how you can be able to calculate volume. Suppose this is in form of a box and you place some soil in it, and then you have the dimensions given. Are you able to determine the volume of the soil? You are able to do that. So let's move on, still on volume. The other thing that we have to note about volume is that since we know that volume can be measured in some other units, actually multiples, then this statement is true. 1 meters cubed is equivalent to 1 million centimeters cubed. So I ask a question here. How many centimeters cubed are there in 1 million meters cubed? Work out the other way. 1 meters cubed is equals to 1 million centimeters cubed. And therefore, how many centimeters cubed are there in 1 million cubed? Then, the other relationship that we should note here is 1 liter is equals to 1000 centimeters cubed. So this relationship is able to help you change or convert given units to other units if you are asked to do that, or in some computations that you may require to use the SI units. What's very important in physics that when you are doing any calculation, you have to employ the SI units that are being used. So if you are given a problem and in the problem they are using centimeters cubed, it requires you to convert them into meters cubed for you to work out and get the right answer. So and that's why this information is very, very important for you. So the other thing that we have to note about volume is that volume can be measured using measuring cylinders, eureka can, we have pipette, burette, volumetric flask, beakers, and other apparatus that are available in the laboratory. Yeah, I know you have a picture of a measuring cylinder, eureka can, pipe, all these ones. These are some of the apparatus that can be used to measure volume. So that's all about volume. The next physical quantity we want to look at is mass. Mass. What is mass? This is the quantity of matter contained in a substance. The quantity of matter that a substance has is what we call mass. There's a difference between mass and weight, as we're going to see later on in the topic called forces. People confuse mass with weight. Mass is the quantity of matter contained in a substance. What about weight? Weight is actually a pull of gravity on a body, and therefore weight is a force, mass is not. Whereas mass of any given quantity or substance does not change, weight changes from one point to the other. For example, if you move from the earth going to the moon, you weigh less, while the same. Something else to note about mass is that matter is anything that occupies space and has weight. We saw this, we discussed this. Any occupies space and has weight, we call that one matter. If you are seated on a seat or a chair, no one else can come and sit on it because you have occupied space. And if you are very heavy and the chair is weak, it's likely to break because you have what? You have weight. That's what this statement means. Matter is anything that occupies space and has weight. Let's just look at this. If you step on a 2 hours baby, you just step on that baby, the baby is going to actually cry because you have a lot of weight. But if the other thing happened, because the baby has very few quantities in him, then you won't feel anything. But the key point here is that both of you occupy space and you have some weight in you. That's why if a colleague stepped on you, you will actually feel it because of the weight or the quantity of matter in it, which is actually affects the gravitational pull of the earth. So something else about mass that we have to note is that the SI units of mass is in the kilograms and the symbols are kg. We have already seen this. Other submultiples used are grams. We can measure mass in grams, milligrams, and tons. And we know 1 kilogram is equals to 1,000 kilograms, and 1 gram is equals to 1,000. 1 kilogram still is equals to what? Is equals to 1 million milligrams, and 1 million milligrams make 100 tons. So this information again becomes very important when you're doing some computations. Density is the next quantity that we have to look at. So, but before you go to that, before you forget, a beam balance is used to measure mass. mass is measured by a beam balance. So moving on, we now want to look at density. So density, this is mass per unit volume of a substance. When you take mass of a substance, then you divide it by the volume of the same substance, then the quantity that you get out of that is what we call density. It's actually the ratio of mass and volume. So if density is the ratio of mass and volume, then what are the units of density? You take the units of mass, divide by the units of volume. So density is measured in kilograms meters cubed. Kilograms are the SI units of mass. Meters cubed are the derived units of volume. Therefore, we measure density in kilograms meters cubed. However, we can also measure density in grams per centimeters cubed. So this is mass. The other thing about mass that is very important is that it is symbolized by rho, and this is the symbol of rho, and it is SI units are kilograms meters cubed. So mass has has a symbol called rho, which is used. When you get a symbol like this one here, rho, that one stands for the density of that given substance. And the SI units of density is kilograms meters cubed. I've just said that we also have derived units that can be used to measure density. This includes grams per centimeters cubed. Now, given that density is the ratio of mass and volume, and the SI units are in kilograms meters cubed, how do you calculate density? Density is given by mass divided by volume. This is the formula. Density is equals to mass divided by volume. So that if you take mass as your numerator in kilograms, divide by volume in meters cubed, you end up with the SI units that we have just. So density is equals to mass over volume. So having said that, let's look at an example that we can use to help us understand what density is. And we have this problem here that we need to solve. A block of glass of mass 187.5 grams is 5.0 centimeters cubed long, 2.0 centimeters thick, and 7.5 centimeters high. Calculate the density of the glass in kilograms meters cubed. The question is very clear here. You have to calculate the density of the block in kilograms meters cubed because these are the SI units of density. How do we proceed? Solution to this. Density is equals to mass over volume. We therefore work out our mass is 187.5 grams, but we convert it into kilograms by dividing with 1,000. Then we divide by the volume. And how do we calculate volume? We multiply length by width by height. That's 2.0. Multiply by 7.5. Multiply by 5.0. But this volume is in centimeters cubed. Therefore, divide by 1 million centimeters cubed that make 1 meters cubed. That's how we work it out. And then what do we get? If we work out all this is what you're going to get. Yeah, what do you get from your own working? Do you get something like this? You get 2,500 kilometers per meters cubed as the density of that particular solid. Up to that end, I hope you have understood what those quantities are and how they can be worked out. Now, from that, are you able to attempt this at your own convenient time? So that is your assignment. The figure below shows the change in volume of a liquid in a measuring cylinder when an irregular solid is immersed in it. So we have the figure. This is our figure. So we immerse an irregular solid in the figure. So here we have it. So study this figure, and then the information from the figure should help you answer the following question. So the questions are: given that the mass of the solid is 540 grams, determine the density of the solid in SI units. What are the SI units of the density? So that's what you have to do. You look at the figure, study the figure, and then help it. It should help you work out that problem. So that marks the end to our today's lesson. I hope you have enjoyed the lesson. Until next time, stay tuned to Elim TV. For more questions, comments, and clarification, you can reach us on our SMS number 40007. You can also visit our Facebook page, Elim TV, and also follow us on Twitter at elimtv_ke. Up to there, thank you very much for watching. Meet next time.